What properties do trapezoids inscribed in circles have? Imagine a shape that fits perfectly inside a circle, touching the circle at exactly 4 points. Now, what special features does this shape have? Let's find out. When a trapezoid is inscribed in a circle, it has some unique properties that set it apart from other trapezoids. First, only an isosceles trapezoid can be inscribed in a circle. That means the non-parallel sides, called legs, are exactly the same length. This equal length is what allows the trapezoid to sit neatly inside the circle without any gaps. Next, in any shape drawn inside a circle, the opposite angles add up to 180 degrees. For an inscribed trapezoid that is also isosceles, this means the angles across from each other on the circle are supplementary. So, the angles at the ends of the longer base add up to 180 degrees, and the same goes for the shorter base. Because the trapezoid is symmetrical, the angles next to each base are equal. For example, the 2 angles touching the longer base are the same, and the 2 touching the shorter base are also equal. The legs of the trapezoid act like chords of the circle, and they cut off equal arcs on the circle. This means the parts of the circle that the legs span are exactly the same. This is a direct result of the legs being equal in length. The shape also shows symmetry. If you draw a line right down the middle, perpendicular to the bases, the trapezoid looks the same on both sides. This symmetry is because the legs are equal and the angles are congruent. Knowing these properties makes solving problems easier. If you see a trapezoid inside a circle, you can immediately tell it has to be isosceles. This helps you find missing angles or side lengths quickly. In summary, the key features of trapezoids inscribed in circles are that they are always isosceles, with equal legs, supplementary opposite angles, and equal angles next to each base. They fit perfectly on the circle's edge, showing clear symmetry and specific angle relationships.